Welcome back. Let's continue with our unit tests. Now, one thing I noticed here is that when looking at the documentation, we actually have an assert is instance. So we can actually, instead of saying assert true, just use the assert is instance, which we give A and B. Again, all these assert methods, there's no right one. You can use whichever one you want as a tool to improve your code. So in my case, let's just change this to assert is instance and fix this like this. So just a little cleaner. Let's see if this works. All right, everything is still good. Okay, let's try and break our code again. So everything is looking good, but what if we do something different? What if we do, let's say, add another test, and we'll say test do stuff 2. Usually you want to name these functions a lot better so they're more descriptive. But in our case, this is fine just so we can see how they work. This time around, let's do test param is going to equal, how about a none type. So now if I run this, let's run this code again. And by the way, you might notice here how I'm copying code in a test. And you might think, well, can we just make this simpler and not repeat ourselves? And you can totally do that and make things a lot easier. But when it comes to tests, because they don't go into production, and this is just for development purposes, you really want to have tests that are easy to read so that other people understand your tests. Because when it comes to testing, readability is really, really important. We don't care as much about not repeating ourselves and making our code efficient, nice and small. So I like writing tests that are really descriptive, really obvious. All right, in here, let's say self.assert equal, and what should this be? Well, in this case, I'm expecting a value error. So let's do this. I expect that the result will be a value error. I'm going to save and run my test. All right, I get an error. It says this is a type error. Int argument must be a string. And I'm giving it a non-type. All right, so this isn't handling it properly because it just doesn't work with the int. We get a type error. So how can we fix this? How can we adjust it in case we get a non-type in the parameter? Well, first off, let's give it a default parameter. Let's say the default parameter is 0. If I run this again, I still get the error. Okay, so we still haven't fixed it. The argument must be a string, a byte-like object or a number, not non-type. Okay, so we're still not checking for the non-type. So another thing we can do is say if number, so we're checking if we have the number value. Because remember, this is going to default to true if it has any sort of numbers or, well, any value. But if it's a non-type, it's going to turn into false. So in here, if number, we can say return this. Else, otherwise, we'll return please enter number. So I'm going to save this and now change this because now we should expect please enter number into my test. And I'm going to say assert equal that result is going to be please enter number. If I now run my test, let's clear this. Looks like I'm getting ran 2 tests in 0 seconds, but we have 3 tests, and that's because you see here that I named mine the same. Remember, if you name the thing the same, well, it's only going to run one of them. So make sure that all the test names are unique. So I'm going to run this. All right, ran 3 tests and everything is working fine. Very, very cool. So you can see here how we went from a very simple function and we started catching these errors and started realizing how our function was too simplistic, that if we received a wrong input, like a string or a non-type? Well, as soon as we did that, our function failed. So by using tests and as testing and breaking things, I was able to improve this function so it's more durable, so that now it works a lot better in production, right? And this is the power of tests. It allows us to check for any mistakes that we may have made, because maybe we wouldn't have thought of doing something like this initially. But by writing tests alongside our code, we were able to improve the function. Now, one last thing I want to add. Let's just add another one over the tests and say that this do stuff for, what if the test parameter is just an empty string? We should get please enter a number. So if I ran this, all right, 4 tests are passing. So it looks like our code is working nicely. Now, to finish off here, I want to just point out a few things. I'm calling here unittest.main, but this has nothing to do with the actual file that we wrote, which is the main file. If, let's say, I rename this, so let's go to my desktop and say I want to change this to script.py. Let's now open this, in my case with Sublime Text. Let's go back here. So you see here that main.py is, well, doesn't exist anymore. It's asking me to save. So this is a completely different file now. If I do script here and simply change all the instances to script, if I save this and now run, this still works. Unittest.main simply says, hey, just run all the tests over here. Now, one thing, and this is a common practice that we've talked about before, is because you want to say, run this file if this is the main file being run, because we don't really want to import test main or anything like this into other files. These are individual files that should only be run when we run our tests. So I can just say if __ name equals __ main, then run this piece of code. So now if I save this and run, there you go. Everything is still working, but now I make sure that this is a test file and I'm only going to run this code if it's the file that's being run, if it's the main file being run. So this is a standard way that you would have your unit test done with the unit test module. Let's take a break and talk a little bit more about tests in the next video.